Today we're looking at Glencoe Accelerated Math, Lesson 5.8, which is on scale drawings and models. So if we talk about something being to scale, that means that we're changing the size, we're keeping the angle measures, and it's in proportion to another. So they're within the same ratio. Where have we seen a scale of something or a model of something? Where can we find those? Yes, ma'am. In what way? Very good. So blueprints are an excellent example. Blueprints have to be drawn to scale, otherwise the people at the construction site don't know how big something's supposed to be. Okay? What else? Yes, ma'am.
Like commercials where they show like comparing things like products.
Okay. That's one way. How else? Anybody else? I'm going to go real old school here for a second. What about a map? No one uses those.
They use Google Maps.
Google Maps.
Hey, now hold on. I told you I was going old school.
You said a map, not Google Maps.
Well, here, do Google Maps have to be to scale?
Yes.
Yeah, otherwise what happens?
You get lost.
It'll be wrong because it says like 600 feet. Right.
And it might be an inch.
Misinformation.
So, a map, which I know most of us are more familiar with Google Maps, but a map has to be drawn to scale. Otherwise, the distance between roads or the distance between landmarks aren't going to make sense. So if I'm driving, let's say that I'm driving down the middle of downtown Florence. Okay, there's a lot of side streets there, correct?
Yes.
All right. If I look at a paper map, it will say on there that 1 centimeter is equal to a quarter mile or something like that. That would be a scale. That would be a scale. The map is a scale drawing because the map is what the city looks like on a smaller surface. Okay? Google Maps uses that same concept, but instead of needing to follow along with your finger as you're walking from one place to another and on different roads, it automatically moves you.
I'd get lost if I tried that.
I'll get in a rut.
What? Believe it or not, maps aren't that much different than Google Maps. Google Maps just moves it for you.
Exactly, but it says how much. It says it out loud. Like, I don't want to read. Right, it tells you.
Yeah, I need to keep
So-
my eyes
so
on the
that-
road.
I don't want to. You just look it up and it goes. You don't have to find all these maps to be able to find
You
one.
just gotta, like,
And you don't have a big piece of paper.
you just, like, if you're going to
Don't
California
waste the trees.
from a different place near somewhere else, then
Or
you don't have to get an app.
Okay, we will have this debate another time. But scales are used a lot in maps. So, if we are looking at example 1 on page 224, can someone read that for me, please? Because I want to solve that problem because it's in a little bit different perspective. Huh? Read it nice and loud for us so that I can hear.
Suppose a model of a dragonfly has a wing weight of 4 centimeters. If the length of the actual wing is 6 centimeters, what is the scale of the model?
Okay. So I know that there's a ratio of 4 centimeters to 6 centimeters. We're going to write this as the scale over the actual being equal to the scale over the actual. So, we want to know if this is 1 centimeter, how large is that in reality? We want to know what that scale is. Okay? So what we're going to do, we're going to use our proportion, that format, to solve. So how do I solve the form of a proportion? How do I solve for that variable? What's the first thing? Yes, ma'am? I cross multiply. And when I cross multiply, what does my first line of work look like?
4x.
4 times x equals what?
4x.
Equals what?
4x.
6 times 1. And what is 6 times 1 simplified? 6. Okay, what do I do from here?
You divide. You find out what
I
x is.
divide. To find out what x is. And what do I divide by? 4. My 4's cancel, and I'm left with x. 6 divided by 4 is what?
2.
No, wait.
2.
1.5.
1.5 or 1.5? Okay. I need units here, so what would my units be? Yes, ma'am.
Centimeters, but I have a question.
Okay.
How do we know that x, that means 6?
How do I know that this is 6?
What you just put under there.
This?
Yeah, how do you know the answer is
6 times 1 is 6.
6? Why did you put 6?
Oh, the 6 there came from the problem. So in the problem we were given that the wing of the dragonfly on the model was 4 centimeters. But the wing of the actual dragonfly was 6 centimeters. So that's my actual amount. This is my scale model quantity. I want to know what's the scale. So what is that relationship? If the scale is 1 centimeter, how much is it in reality? That answer is 1 1/2 centimeters. Okay? Yes, ma'am.
How do you know you divide by 4?
How do I know that I need to divide by 4? Because we divide by the number that's attached to my variable. Okay? So in this instance, 4 was attached to the variable. Our goal once we get to this step is to get the variable by itself.
So, why did you cross out the 4?
Because a 4 in the numerator and the 4 in the denominator, that's like saying 4 over 4 is a fraction, which simplifies to be 1. So they cancel each other out, leaving us with the quantity x. Okay? Yes, ma'am? The 1 centimeter? Because we can only have one variable in a proportion. So we know that we're looking for the scale, which is looking for 1. If the scale is 1, what is my actual going to be? That's what we're trying to find out. Okay? Alright. Anybody else? Yes, no, maybe?
No. Maybe so.
Okay. Let's look at one more example. This was example 1, correct? Alright. Please turn and look at page 226, example 3. 226, example 3. Now, this is on creating or graphing a scale model. We are not going to be drawing the model. We're going to be finding the dimensions for that model. Okay? Yes, ma'am. You want to read it for me? Please. I'd love it.
Life in the pool or moral acts of on a wall that measures 18 feet long and 12 feet tall. Make a scale drawing of your scale. 1/4 inches equals 3 feet. And
Okay.
1/4 equals inch grid paper.
Okay. So a 1/4 inch is equal to 3 feet.
She said that.
Yeah.
All right. Like I said, we're not going to be drawing this on grid paper. Using 1/4 inch grid paper, what that means is that each block would represent 3 feet. Okay? We're going to be finding out how large that would be without drawing it on the paper. All right? So, we need to know, we have our scale here. Our scale says that 1/4 inch of scale is equal to 3 feet in real life. So does this have to be a 1? No. If we're given a scale, it can be multiple different things. Okay? Let's start with the wall that is 18 feet long. So if my wall is 18 feet long, I need to figure out how large I need to draw it in my scale. So in this problem, because there are 2 dimensions on the wall, there's a length and a width, we're going to be finding this twice. Yes, ma'am? Did you have a question? Okay. What do I do to solve this proportion? I need to cross multiply.
I said that, but I was wrong.
When I cross multiply, what does that give me? What do I write for my first line of work?
Wait.
1/4 times 18 equals what?
3 times 4. Oh wait.
Equals 3 times what? 3 times x. 1/4 of 18 is what? What? 4.5. 3 times x simplified is what?
3x.
3x. Then what do I do?
5.
Divide by what?
3.
Divide both sides by 3. What is 4.5 divided by 3?
1.5.
That equals x because these 3's cancel each other out. What units go here? Inches. Alright, so we figured out what one wall length was. Now we need to do the other one. What were the dimensions of my room? It was 18 feet by what? Go back to your problem.
12.
12 feet, okay? So, we still have the same scale. So we're still going to use 1/4 inch over 3 feet, but we're going to have x over 12 feet instead of x over 18 feet. So now what do I do? I cross multiply.
Cross multiply.
And when I do that, what is my first line of work going to say? 3 times x equals what? 1/4 times 12. 3 times x is 3x. 1/4 of 12 is 3. Alright? What do I do next? By what?
3.
3 divided by 3 is 1. These 3's cancel and I'm left with x. What are my units that go with the 1?
Inches.
Inches. So, I would say then that my model for this mural is going to be 1.5 inches by 1 inch. That's going to be the scale. That means that on a piece of paper, this mural that is actually 18 feet by 12 feet will be shown as 1.5 inches by 1 inch. Yes.
This doesn't pertain to this, but
Okay, then let's wait till after the video.
okay.
Then I promise I'll answer your question. What other questions do we have? None? We're good to go?
Yeah.
Fantastic.